Hey guys, so today we're going to go over the minimum depth of a binary tree, the LeetCode question, which is easy. So given a binary tree, find its minimum depth. The minimum depth is the number of nodes along its shortest path from the root node down to the nearest leaf node. Note, a leaf is a node with no children. Great, so it should be from this one, from 3 to 9, which would be a length of 2, as you can see here. So we first want to get rid of our base case, so we just have an if statement, and we check if root is equal to null. If that's the case, we return 0, and that's our base case done. So we also want to recursively traverse down the tree to find the left and right minimum values, right? So we have a left minimum value, and we traverse down the left part. The same thing for the right side, so we recursively call both of these. And now we want to have an if condition. We want to check if either the left min value is equal to 0 or the right min value is equal to 0. What we want to do is we want to return left min plus the right min plus 1. So I'll explain this in a bit. And if this condition isn't met, then we still need to return something, right? So we write a return statement. Inside the brackets, we check whether left min is less than the right min. And if it is, we return the left min. If it isn't, we return the right min. We also have to plus 1 to account for the current node that we're at. So if we run this, right, so some people get confused about why we have to return the left min plus the right min plus 1, and why can't we just return 0 in this case. So let's say we have 3, 20, and 7, and we don't have the 15 node here, right? So let's suppose that we're already up to the 20 node. So when we're at 20, we realize that the left node is null. So like in our hypothetical scenario, 15 doesn't exist, right? So if the left node is null, then it would go into this condition and realize that it's null, and it would return 0, which would be wrong, right? If we return 0, it would be wrong. However, in our case, we return left min plus right min. And in this case, left min is essentially just 0. So it's in actual fact, it's just returning right min plus 1. And right min is just the minimum path, right, on its right side. And then plus 1, which just accounts for the current node that we're at, which is why we have to return left min and right min. So in the case where right min is 0, right, it will just be left min plus the current node that we're at. So in this case, either one of these will be 0, so that's why we can plus them together, plus the current node that we're at. So if we submit this, as you can see, it beats almost 94% and 95%, which is really good.